Alright, so here's my circuit. It's pretty much working right, but I can't seem to get the square wave oscillator down here completely functioning. The way the circuit works is I cascade an LC bandpass from an LC notch resonant filter, and that LC notch is set at around 1 kilohertz, while the bandpass resonant frequency is around 7 kilohertz. The goal being to fully attenuate frequencies in the human voice range while fully select for frequencies of interest for whatever timer or appliance is going off. That's what these are. Those are fed into a non-inverting amplifier with gain 100, because a microphone signal will invariably be very small, and that has a Zener diode to ground to provide voltage regulation as it's fed, as this stage is fed into the full wave bridge rectifier. In the next stage, if you follow this green wire here and then this red wire, you see that this leads into a full wave bridge rectifier that is put into a smoothing capacitor and a bleeder resistor for safety purposes. These in turn, with this green wire right here, drive a comparator, an op-amp comparator with a threshold of 0.5 volts that will only trigger if the frequency that's driving the circuit is in the range of about 6.5 kilohertz to about 7.8 kilohertz. So this comparator right here will only go high. It will only go to 9.6 volts, which is what it's currently at, if the input frequency is in about 1,000 hertz band, around 7 kilohertz. That's effectively what I wanted. This means that it could drive an NMOS, or it could switch an NMOS and let an oscillator signal through. Unfortunately, the NMOS didn't work the way it was supposed to. I spent several hours trying to get it to work. Actually, same with the microphone, but neither worked. And yeah, so there's the circuit. The square wave oscillator isn't quite working right now either, but basically the most challenging part was getting this frequency response. As you can see here, it's 7. This is driving this, as you can see, and it's 7 kilohertz, and this right here goes to this point across the comparator here, between ground and the comparator output. So this is the output voltage of the comparator. As you can see, the op-amp won't quite go to VDD or VSS, so with 10 volt supplies it settles for about 9.6 volts. And anyway, yeah, so that's 7 kilohertz. We get 9.6 volts output from the comparator. And then watch this as we sweep the frequency down. So 6.7 kilohertz. I'm still up. Now it's gone down a little bit because the op amp doesn't function perfectly, but it's gone down. Basically still at 9 volts, and so it would still go high. It still is high in this case. And I bring it down a little more. Now it's at 8.6 volts. When I drive the circuit with 6.5 kilohertz, still high. And finally, that's the transition that does it. 6.5 to 6.4 kilohertz. And now look where the output voltage on the comparator is. Negative 9.456 volts. So now it's low, and it would have a completely different effect on an N MOSFET. So on the other end of that frequency band, because the goal of this circuit is to only select for a specific frequency, that of a certain timer or a certain alarm or something like that. So we see on the upper end of this frequency range, so we're back to 7 kilohertz. As you can see, 7.3 kilohertz. We're still at 9 volts. 7.5. Now we're down to 8.8 volts. And once we hit 7.8, that is the first time. Now we're at negative 9.5 volts on the comparator output here, which is this guy right here from a 411. So yeah, because the FET switch didn't work, what I am planning on doing, if I have enough time here, is trying to get this oscillator to be driven, or have its VCC be the output of the comparator, and its VEE be the negative rail voltage. That way, if the comparator goes high, it'll have the split supply that it needs to produce an oscillating output. But if the comparator goes low, it'll have 2 negative DC supplies, and so it can't produce its square wave output. Therefore, it won't drive the speaker with the LED. That will be indicative of sensing this frequency. So yeah, that's basically the circuit. As long as I can get the square wave oscillator to work, it should drive the speaker and the LED pretty effortlessly. Yeah, that's it.